लुम्बिनी टिभी एसडी।
नमस्कार सबैलाई। लुम्बिनी सामुदायिक टेलिभिजन र बुद्ध सामुदायिक टेलिभिजन हेरेर बसिरहनु भएको सम्पूर्ण अभिभावक तथा विद्यार्थी भाइ बहिनीहरुमा बुटोल उपमह नगरपालिकाद्वारा सञ्चालित यसई तयारी कक्षामा स्वागत गर्न चाहन्छु र म विज्ञान शिक्षक विकास हमाल हजुरको सामु उपस्थित भइसकेको छु। र विद्यार्थी भाइ बहिनीहरु आज हामीले फिजिक्सबाट नयाँ लेसन लाइट सुरु गर्न गइरहेको छौं। सो लेट्स डिस्कस on this new lesson, that is the light. Simply light, which we had studied in the junior classes also, is the form of energy which gives the sensation of vision to our eyes. With the help of this light, we will be able to see the object. What the thing is that when the ray of light or the beam of light falls on any object, the ray of light, after striking on that object, the ray of light will get returned back. That process is known as the reflection of light. And after reflecting the ray of light falling on any object or any surface, when it reaches to our eyes, and inside the eyes it enters or it reaches to the retina. And after reaching into the retina, the image which is formed on the retina, that is carried to the brain with the help of the optic nerve, and then only we will be able to see the object. This is what about the light. But light itself, it is invisible, but makes the thing visible. And the object which is seen with our eyes, all the objects which are seen with our eyes, they are not, they may not be clear. Normally, or the that is nearby our surroundings, whatever the object which we see, which are of the normal size, okay, that can be seen easily without using any instrument. We can see easily. But there are some objects, the tiny objects, which are not seen with our eyes clearly. Okay, to see these objects, we have to use what? We have to use microscope. That is the thing. In the same way, such as the distant object, very far objects, like the heavenly bodies, we cannot see these objects clearly. To see this object, what do we use? We use the telescope. That is the thing. Such type of instruments like the microscope, in the same way the telescope, which are used to see the objects clearly. Those objects which are not clear, and with the help of these devices or with the help of these instruments, okay, these objects now become visible to us clearly. Such type of instruments which are used to see any objects clearly, they are known as the optical instruments. This is the thing. So optical instruments are those instruments which are used to see the objects clearly, and all these optical instruments, they consist of the lens. Now what is this lens then? Now let's discuss, which is given there in the screen. That is, lens is a piece of transparent glass or the plastic bounded by two refracting surfaces which are usually spherical in shape. Actually lens, which are made up of the glass or the plastics, okay, and they are transparent also, but which consist of the two refracting surfaces, okay, and usually they are spherical in shape. And these lens, now they are of the two types on the basis of the shape and on the basis of the structure. One is the convex lens, and next is the concave lens. So it is what about the types of the lens. Now what do you mean by this convex lens? In the same way, what do you mean by this concave lens? Now convex lens, okay, those lens which are thicker in the middle and thinner at its edges. That is, in the middle it is thicker, it is the middle part of the lens, and these are what? These are the edges of the lens, and which are thicker at the middle and thinner at its edges, that is known as the convex lens. And the lens which is thinner at its middle and thicker at its edges, that is known as the concave lens. My dear students, just I think you might have seen just before in this screen also, that is the image or the figure of this convex lens and the concave lens on the basis of the structure, okay, that is the thing, which are thicker at its middle and thinner at its edges, known as the convex lens, and which are thinner at its middle and thicker at its edges, they are known as the concave lens. So it is what about these convex lens and the concave lens. And now this convex lens, when the parallel beam of light, one thing just you be clear that ray of light, and next is the beam of light. What does it mean, ray and the beam of light? And ray, it is the single unit of light that is known as the ray of light. And if two or more than two, rays of light, or the collection of the rays of light, that is known as the beam of light. It is the thing now. So when the parallel beam of light that is incident on this convex lens, now the parallel beam of light, they are converged after refraction. Now the term refraction, that is the bending of the light when it goes from, that is the one medium to another medium, that is known as the bending of the light. And the parallel beam of light falling on this convex lens, just they meet at a point after refraction. So why this convex lens, it is also known as the converging lens. And now this concave lens, the parallel beam of light falling on it, it diverges. So why it is also known as the diverging lens. Now the question may be asked, that is the convex lens is also known as the converging lens. Why? In the same way, concave lens is also known as the diverging lens. Why? Now the question may be asked. That is the convex lens is known as the converging lens because the parallel beam of light which is falling on this lens, now they meet at a point after refraction, just which can be just shown in this slide also. That is just I had shown, just I instruct the technician brother to show in the slide also. That is the next slide. Yeah, see there, that is the convex lens is also known as the converging lens. Here we can see there in the figure, that is the parallel beam of light which is falling on the lens. Now they are converged after refraction. So why it is known as the converging lens. In the same way, now the concave lens is also known as the diverging lens because the parallel beam of light which is falling there on that what do we say lens, that it has been diverged. So why it is known as the diverging lens. So it is the thing. And in the same way, now the convex lens and the concave lens, now again they are of the three types on the basis of this and the size. Just before we have seen in the screen also, that is the types of this convex lens and the types of the concave lens. Now this convex lens, they are of the three types. In the same way, concave lens also they are of the three types. That is, they are the biconvex lens. In the same way, next, that is the plano-convex lens. In the same way, concavo-convex lens. These are the three different types of the lens. In the same way, next, that is the types of the concave lens. They are also of the three types. One is the biconcave lens. In the same way, next is the plano-concave lens, and next is the convexo-concave lens. These are the three different types of the concave lens. My dear students, this is very important question. What are the types of the lens? This question may not be asked, but what are the types of the convex lens and what are the types of the concave lens? And draw figure for each also the question may be asked, and that image, that figure, very, very important for your exam point of view. My dear students, don't forget to see these types of the convex lens as well as the concave lens along with the figure also. So it is what about these, do we say, the lens. And now this lens, the convex lens, it converges the parallel beam of light falling on it. In the same way, concave lens, it diverges the parallel beam of light which is falling on it. Now why do this convex lens, it converges the parallel beam of light falling on it? This is also the thing. Why is this convex lens known as the converging lens? Just before we had discussed, because it converges the parallel beam of light. It is also the lens and it is also the lens. This is the thing. But what the thing is that although both of them, they are the lens, but it converges the parallel beam of light and it diverges, just before we saw in the figure. But now why it converges then? For that we have to go to the concept. That is, both the convex lens as well as the concave lens, they consist of the set of the prisms. Okay, that means convex lens also consists of the group of prism. In the same way, concave lens also consists of the group of prism. In that, okay, and regarding this prism, we had already studied in grade 9 that we had studied, that is the dispersion of light through the prism. That prism simply consists of the base, okay, and next it is the angle, and any ray of light which is falling on this prism, okay, always it bends towards the base, always. That is the thing, and that we had discussed in grade 9 also, that is in, and we had studied in this ray diagram also, that is the dispersion of light through the prism, that we had discussed, my dear students. Okay, now this convex lens now, okay, why it converges? For that, okay, we have to know the concept of that prism. That means this convex lens, it consists of the set of prisms or the collection of the prisms. Now see here, let's see in this way, see, that is the thing. In the same way, next, like this, consist of the prisms, set of prisms. Now, my dear student, let's see here. Okay, in this, now there are these lens, that is the convex lens, is divided into the 5 different parts. Out of which this middle part, okay, it is what? It is not the prism. Okay, this middle part, it is the glass slab. Okay, and now it is the glass slab, and when the ray of light falls normally on this glass slab, okay, then it does not bend, it goes straight without bending in this way. But now here these are the prisms now, see. Okay, this is the angle, it is the base, it is the angle, it is the base. In the same way, these two are also what? These two are also the prisms. Clear? This is the base and it is the angle, this is the base and it is the angle. That is the thing, clear, which consists of this here. That means upper 2 prisms and the lower 2 prisms, and middle one, it consists of the glass slab. Now, when the parallel beam of light, now it is falling on the lens, that means the parallel beam of light, okay, they are falling on the prism. That means the upper prism, the base is just facing downward, and the lower prism, base is facing upward. Isn't it? So why now when the parallel beam of light is incident on this prism, now in the upper prism, the ray of light that will be bent, okay, the ray of light that will be refracted towards the base means in the downward direction in this way. That is the thing. See, it is what. And my dear students, keep in mind, clear, in this light, okay, to show the ray of the light, this arrow is very, very essential. Right? This arrow, it plays the vital role, which shows the direction of the light. That is the thing. In the same way, now if we show in the lower part, that if we see that is the prism or that is the lower prism, the base they are facing in the upward direction. That means now the ray of light falling on it, here that will bend, and that bends in the upward direction, and finally just will meet at a point. Clear? So why this convex lens is known as the converging lens, or so why this convex lens, okay, it converges the parallel beam of light falling on it, because the upper prism base are facing downward and the lower prism base are facing upward, isn't it? And since the upper prism, the base are facing downward, refracted ray of light that are bent downward, and the lower prism base are facing upward, refracted ray of light that will bend upward, and finally they will meet at a point after refraction. That means the refracted ray of light, they are converged. Okay, so why this convex lens is known as the converging lens, or also what can we say, that is the convex lens, it consists of this set of prism. Now in your examination the question may be asked, hey, how does the convex lens converges the parallel beam of light falling on it? Explain with figure, the question may be asked, and all this explanation that you have to along with the figure. Okay, in the same way, the convex lens consists of the set of prism. Justify it. Also, the question may be asked. Yeah. In the same way, next, that is the concave lens also. Okay, that is the concave lens also consists of the set of the prism. Just before we saw in that slide jointly also. See there in these diverging lens or the diverging prism that consists of the 5 different set, middle one that is the glass slab, and the upper 2 prisms, okay, and the lower 2 prism. In the upper 2 prism, that is the base, they are facing upward, and the lower 2 prisms, okay, the base are facing downward. So when the parallel beam of light, they are incident on the upper prism, now the ray of light, they are diverge, okay, they are going upward. In the same way, when the parallel beam of light, they are falling, okay, on the lower prism, okay, the refracted ray of light, they are diverged just in the downward. So they are going away from each other. Okay. So it is what about this converging lens. In the same way, next, that is the diverging lens. Why the convex lens converges the parallel beam of light, and why the concave lens diverges the parallel beam of light. I think students, you are clear regarding this concept of this convex lens as well as the concave lens. Now, some terminologies related to the lens. Okay. Some terminologies related to the lens, that is the first, that is center of curvature. That is the thing. So, center of curvature is the center of the lens. Okay. Center of curvature is the center of the sphere of which the lens is a part. That means the how the convex lens is made and how the the concave lens is made. Simply both the convex lens, that is the biconvex lens, as well as the biconcave lens, both of them, okay, they are made, okay, they are made up of the sphere like this. Now see, two spheres, see here, let's see in the whiteboard. Okay. Now see, first sphere and the second sphere, which consists of the center C1 and the second sphere center C2. C1 and C2, they are the center of the sphere. In the same way, second, now the two spheres C1 and next C2. Now, okay, what can we do that? This part that can be removed. See. So now it is what? It is the convex lens, and this is the convex lens here, which is the portion or which is the part of these two spheres having the center C1 and C2. In the same way, now what can be done? See, it can be joined. Now this can be removed. See. Now it is what? It is the concave lens. Okay, and it is the portion of the two sphere, yeah, which has the center C1 and the C2. Clear? So now this C1 and C2, this C1 and C2, they are known as what? They are known as the center of the curvature. So center of curvature is the center of the sphere. Okay, the center of the sphere of which this lens is a part. That means this convex lens as well as the concave lens, they are the part of this sphere. That is what about the center of the curvature, and which is always represented by C1 and C2. That means a lens has the two centers of curvature, which is represented by C1 and C2. And okay, the line joining, now when this C1 and C2 they are joined, always, okay, it passes through the center of the lens or through the middle of the lens. Always, that is the thing. See, it is what? And this line joining between the two center of curvature of the lens, that is known as the second term, principal axis. This is the thing. That is a straight line passing through the two centers of curvature of a lens, that is known as the principal axis. In the same way, now in this lens, either in the convex lens or in the concave lens, now in this principal axis, just at the center of this convex lens or the center of the concave lens, now that is the main center, okay, of the lens, which is also known as the geometrical center of the lens. That geometrical center of the lens, either of the convex lens or of the concave lens, that is known as the optical center. It is the thing. And this optical center, it is represented by capital O, and always, okay, that is lying at the center of the lens, and that must be always on the principal axis. And the properties of this, okay, that we have to know is that is any ray of light that is passing through this optical center in this lens, either in the convex lens or in the concave lens, any ray of light passing through it, okay, goes straight without bending or goes straight without deviation. Now, okay, just before what we saw, see here, that is the parallel ray of light falling on it, just it was bent. But here, now any ray of light, okay, just it is falling on it, now just passing through the optical center, okay, it goes straight without bending. This is the thing that you must have to know. Okay, not only in the convex lens, in case of the concave lens also goes straight without bending. Here also same, like this, here, goes straight without bending. Here also same, that is goes straight without bending. This is the thing. Yeah, so it is what about this optical center. Okay, now the next term, that is principal focus. See, principal focus. Just before that we had discussed convex lens, it converges the parallel beam of light falling on it. In the same way, concave lens, it diverges the parallel beam of light falling on it. Now, let us see here in the figure, that is in the whiteboard. Now, see, what is it? It is the convex lens, and what is this? It is the principal axis, and this point, that is the optical center. Now, when the parallel beam of light that is falling on this convex lens, okay, now it will refract, and after refraction, now they will meet at a point. This is the thing here at this point. See, it is the thing. In the same way, now in case of the concave lens, what is this line? Known as the principal axis. What is this point? That is the optical center. Now, parallel beam of light which is falling on it, now, okay, they do not meet, but they go away from each other, they diverge. But what the thing is that in this case now, okay, just when they are proceed backward direction, that is the imaginary line, which is also known as the virtual line. This also, that is the diverging ray of light. Now, when the imaginary line they are proceed backward, now they appear to meet at a point. That is the thing. Oh, this point, okay, they are meeting really, clear, and here they are meeting virtually. Okay, oh, this point, that is when the parallel beam of light that is falling on the lens, either the convex lens or the concave lens, okay, and after refraction they meet or they appears to meet at a point. Oh, this point, that is known as the principal focus, which is represented by capital F. So it is what about the principal focus. Now, what is the definition of this principal focus then? That is the point on the principal axis in which the parallel beam of light falling on it, they meet or appear to meet at a point, okay, after refraction through it, that is known as the principal focus. Okay, so it is what about the principal focus. And now, okay, here the distance between this optical center and the principal focus. Let's see here in the whiteboard. Yeah, this is the distance in case of the convex lens. In the same way, in case of the concave lens. Now, this is what the distance. Oh, this distance between the principal focus and the optical center of the lens, or distance between the principal focus and the optical center of this distance, that is known as the focal length. That is the thing. So, next term, that is focal length of the lens, and this focal length, it is represented by small f. That is, now keep in mind, that is capital F and the small f in case of the lens. You must have to be clear. Okay, that is capital F means the point, okay, which is known as the principal focus, okay, where the parallel beam of light falling on the lens, they meet or appear to meet at a point after refraction. In the same way, small f, it is the length or it is the distance between the optical center and the principal focus. Okay, and now here in this case, in case of the convex lens, okay, the parallel beam of light, they are, okay, after refraction they are really meeting. That means this principal focus, okay, it has been obtained by the intersection of the real refracted ray of light. But here in case of the concave lens, okay, that is the parallel beam of light, okay, just they are just appearing to meet at a point, okay, after refraction, not really, virtually. clear, just they meet at a point, okay, virtually after refraction. So why here, that is this, what do we say, that distance, okay, focal length in case of the convex lens, that is taken as the positive for the convex lens and is taken as the negative in case of the concave lens. My dear students, now what the sentence may be there is that the focal length of a lens is 2 centimeter, this sentence, and focal length of a lens is minus 2 centimeter. Okay, if such type of statement or if such type of sentence that you see, clear, then what you must have to know that is the focal length of a lens is 2 centimeter, that means positive is what? It is the convex lens. In the same way, focal length of a lens is minus 2 centimeter, see, negative, that means what? It is the concave lens. Okay, so this is also one of the way or the method to identify whether it is the convex lens or whether it is the concave lens. Okay, that is the focal length is positive for the convex lens and is negative for the concave lens. And now the next terms that you must have to know, that is the focusing, right? Define focusing or state focusing, that repeatedly asked question in your 1 marks in your examination. That is the focusing is the process of making the sharp image on the screen, okay, with the lens by changing the distance between the lens and its screen, where that is known as the focusing. Okay, that means the process of formation or making the sharp image on the screen by adjusting or by moving the distance between the screen and the lens, okay, where the sharp image is formed or where the clear image is formed, clear, that point, okay, is known as this principal focus, and distance between the lens and that principal focus known as the focal length, okay, and that process is known as the focusing. Okay, so these are what about some terminologies, okay, that you must have to know related with this lens. Okay. Now next, that is the rules to draw the ray diagram or rules for the refraction of light through the lens, okay, that is through the convex lens or the concave lens. That is, the property is same, that is in either in the convex lens or in the concave lens. First, that is shown in the screen also, that is in both the lens, either in the convex lens or in the concave lens, the ray of light passing through the optical center goes without deviation. Goes without deviation means goes without bending. Just before we had discussed, at the time of discussing the optical center also, that we had discussed, okay, any ray of light passing through the optical center, okay, either in the convex lens or in the concave lens, goes straight without bending. In the same way, next, that is the second point, in case of the convex lens, okay, the parallel ray of light, okay, or a ray of light that is parallel to the principal axis after refraction or after bending passes through the principal focus on the other side of the lens. In the same way, next, in case of the concave lens, the ray of light, okay, that is passing parallel to the principal axis in case of the concave lens appears to diverge from the focus on the same side of the lens. Right? In the same way, next, that is the third, a ray of light that is passing through the principal focus after refraction always will be parallel to the principal axis. And next is that a ray of light that is directed towards the focus after refraction always goes parallel to the principal axis. So these are the 3 rules, and the most important is that the first and the second rule is very, very important in your level to draw the ray diagram. So now, after discussing these rules, now let us draw the ray diagram, that is in case of the convex lens. Now, how to draw? So let us see here. Now it is the lens. Now what is this line called? This line which is passing through the center, that is known as what? That is known as the principal axis. And the geometrical center of the lens, what is this point called? Known as the optical center. Okay, and now this point where the refracted ray of light that meet, represented by capital F, what is that called? That is known as the principal focus. And keep in mind that, okay, not only the parallel ray of light passes from this direction, parallel ray of light may pass from this direction also in this way. And when the parallel ray of light pass in this direction, now at that time refracted ray of light that may meet here. But now at that time the distance between this O and F will be same, that is in the another side also. So that F may be in the another side also. That means the principal focus will be on both the sides. So it is what? It is the principal focus. It is also the principal focus, but keep in mind the distance between this O and F and this O and F, that will be equal. Okay. In the same way now, this distance between this O and F, what is it called? It is known as the focal length. It is the thing. And now same distance, that is the focal length, if we take from this F, from this principal focus, now suppose it is here, and this point, that is known as the 2F, which is also known as the center of curvature. Okay, it is the thing, center of curvature. In the same way now here, same distance if we take it, clear, that will be point 2F, which is also known as the center of curvature. Optical center, principal focus, center of curvature. Optical center, principal focus, center of curvature. Okay, and now distance between O and F, it is known as the focal length, and distance between the O and, that is the 2F, center of curvature, that distance is known as the radius of curvature. Keep in mind that radius of curvature is represented by R. Keep in mind, my dear students, that is center of curvature, it is the point, okay, that is the 2F, this 2F, okay, and radius of curvature, that is the length, or that is the distance between the O and the center of the curvature, or the optical center and the center of curvature. Okay, so it is a thing. Now suppose, now let us say that here is the object. This is what? The object. Now from this object, that is AB is the object, now parallel ray of light is incident on this convex lens. Now when it is incident, or when it is falling on this convex lens, now rule number, that is the second, the ray of light parallel to the convex lens, okay, the incident on it after refraction, it passes through principal focus, that we had discussed. In the same way now, next ray of light, same from this object, now will passes through the optical center. When the ray of light, okay, passes through the optical center, that is the rule number first that we have seen before. Okay, any ray of light passing through the optical center now goes straight without bending, or goes straight without deviation in this way. That is the thing. That means this is the point, okay, which is in the another side of the object. Yeah, another side of the object where the refracted ray of light, they are really meeting. Okay, this point where the refracted ray of light, they are really meeting, at that point the image of the object is formed by this lens. This is the object, and now the image is formed at this point. Now what is the size or what is the height of this image, okay, just that is formed by the lens? Now what we have to do, we have to draw the perpendicular line. Okay, we have to draw the perpendicular line to the principal axis. Now see, let us draw the perpendicular line to the principal axis from this point of intersection, and now that image, okay, which is formed, now it is what? It is the height of the image, or it is simply the image. Clear? And now this is the image which is formed, clear, by the intersection of real refracted ray of light. Such type of image which is formed, clear, that is on the another side of the object, and which is formed, clear, by the intersection of the real refracted ray of light, such type of image, that is known as the real image. And the thing is that this real image, they are always inverted in nature. This is the thing. So now inverted means what? The thing is that suppose here now, this is the object here, whose cap is here up, this black portion, here cap is up. Okay, and it is what? It is the object. Now the object is now inverted. Clear? The image of the object is inverted. What does it mean now? Inverted means just upside down. Clear? It is the thing. That means here now it is the object, B is up, clear, this cap is up. Now inverted means what? It will be down in this way, that is B dash now A dash. It is what? It is the image, and which is the real image, because it is formed by the intersection of real refracted ray of light, okay, and in the another side. Yeah. So it is what, or it is how the what do we say, the image of the object is formed by the convex lens. And now next is that the distance between this lens and the object, this AB, it is the object, and now it is the lens. This distance between the image and lens and the object, that is known as the object distance, and this object distance, it is always represented by small u. And now here it is what? It is the image. Here A dash, B dash, it is the image, and now the distance between this lens and the image, okay, that is known as the image distance, and this image distance, it is represented by small b. Okay. So now image distance is the distance between the image and the lens, represented by small b. In the same way, object distance is the distance between the object and the lens, represented by the small u. And now here AB, it is what? It is the height, or it is the size of the object. Here, this AB, which is the height or the size of the object, that is known as the height of object, and this height of object, it is represented by capital O. In the same way, now this A dash B dash, it is what? It is the image. Clear? And now this A dash B dash, which is the image, that is known as the height of image. It is the thing. Okay, and this height of image, it is represented by capital I. This is what. And now clear, what the thing is that the image which is formed by the lens, either the convex lens or the concave lens, now the image may be bigger than the object, the image may be smaller than the object, or the image may be, what do you say, same size as the object. Now if the image which is formed here, that is bigger, then what terms that we use to describe is that if the image is bigger, then that is known as the magnified image. It is the thing. In the same way, if the image is smaller, what term that we use, that is the diminished. The image is bigger, then we say the image is magnified. If the image is smaller, the image is diminished. And if the image is equal, then what do we say? That is the same size of the object. These are what the terms that we must have to know, that is while drawing the ray diagram, that is how is the image, whether it is magnified or whether it is diminished or whether it is same size. Magnified means bigger, okay, in the same way diminished means smaller, and the same size means that is the equal size. Now it is what the ray diagram, that is the formation of the image, okay, by the convex lens, in the same way by the concave lens. Now it is the concave lens. See here, what is it? It is the, just see here, they are in the whiteboard here. Now that is concave lens, and now it is what? It is the principal axis and the optical center. Now see here, okay, and now it is the principal focus, center of curvature, principal focus and center of curvature. This is the thing. Okay. Now in the same way, here is the object, that is A, B. Now when the parallel ray of light fall, okay, now it will diverge, but what the thing is that it appears to pass through the principal focus. It is the thing. Okay. In the same way, now next ray of light passing through the optical center goes straight without bending. That means it is the point where this, okay, ray of light they are meeting, and this, from this point where the ray of light they are meeting, now is not the real, okay, refracted ray of light. That is what? It is the virtual, that is the imaginary ray of light is meeting here. And it is what? From here now we draw the perpendicular line, that is the image. And now this type of image, okay, just in the whiteboard I would like to show here. Now this is the image clear, which is formed by the intersection of the imaginary ray of light. Clear? Oh, such type of, what do we say, the image which is formed, clear, by the imaginary ray of light, such type of image, that is known as the virtual image. It is a thing. Clear? Now it is the image which is formed by the intersection of real refracted ray of light, but here it is the image which is formed by the intersection of the virtual ray of light. Okay, and such type of image known as the real image, but here that is on the virtual image. And always here that virtual image, they are on the same side of the object, and the real image, they are in the opposite side of the object. Now my dear students, okay, now in your examination the question also may be asked, differentiate between the real image and the virtual image भनेर सोध्न सक्छ है. That is real image, okay, it is formed by the intersection of the real refracted ray of light, and the virtual image formed by the intersection of the virtual ray of light. Okay, and real image, they are always formed on the opposite side of the object, and the virtual image, they are formed on the same side of the object. Okay, and real image, they are inverted, but the virtual image, they are always erect. Now erect means, now suppose this is the object. Clear? If it is the object, now the image, that the cap is up. Clear? The object is also same like this. Okay, it is what, that is the cap is up. Clear? So this is what about the real image, and next is the virtual image. Now here just I had made the slide, that is the ray diagram, okay, on the different condition, that is of the image which is formed by the convex lens. Okay, there are the 6 cases. Okay, and just in the screen which is shown, that is the concave lens. Okay, just before it was shown that the 6 cases, that is when the object is at infinity, in the same way when the object is at 2f, in the same way when the object is beyond 2f, when the object is in between f and 2f, when the object is at f, and when the object is in between f and o. So my dear students, okay, what you must have to know is that is while drawing the ray diagram of the convex lens of the 6 cases, okay, the 3 things that you must have to know of the image which is formed. Where the first, that is the position of the image which is formed, that is on the same side, or the, what do we say, in the opposite side of the object. Okay, in the same way, next, that is the size, that is the size of the image, whether it is bigger or whether it is smaller or whether it is the same size, and next, that is the nature. Okay, now the just before that we have seen in the slide, that is the convex lens. Okay, that is the 6 cases when the object is at infinity. Infinity means, just I like to request to show that the convex lens one slide in the screen, that is when the object is at infinity. Infinity means the object is very far, the object is, what do we say, at this infinite distance, and at that time the object is very big and the parallel ray of light will come, and finally the image is formed. Where is in the figure, that is the image is formed at f. Okay, when the object is at infinity. And now what is the size of the image? Is smaller. Okay, the smaller also, that is the just the point or not, there is a point mother. Okay, tell your image, that means that is diminished, also highly diminished. Okay, it is the thing. And now nature. Okay, object is in one side and the image is in another side, that is what, it is the real image. So nature is that real and inverted. In the same way, next, that is the convex lens, that when the object is just beyond 2f. Okay, when the object is beyond 2f, now the image is formed in between f and 2f, real. Okay, in the same way, this image is diminished. When the object is at 2f, image is also at 2f. When the object is in between f and 2f, the image is, okay, beyond 2f, but the magnified image real. Okay, and inverted. When the object is at 2f, the image is at infinity. Okay, and is real. Okay, and the size, that is the magnified. And now next, that is when the object, okay, is in between principal focus and the optical center. Now see there, okay, the image is formed on the same side, there is the virtual ray of light is there. Okay, and that virtual ray of light, okay, just now they are intersecting, that means the virtual image is formed. Now my dear students, हजुरहरुलाई जाँचमा यो क्वेशन सोध्दाखेरि draw the ray diagram when the object is at this भनेर आए त सजिलो हो यो क्वेशन, तर क्वेशन कसरी सोधिन सक्छ त भन्दाखेरि, in which condition does the convex lens form the virtual and magnified image, draw the ray diagram for it भनेर क्वेशन सोध्न सक्यो नि त अब है. त्यो भयो भने अब हजुरहरुले के गर्नुहुन्छ त भन्दाखेरि, अब when the object is at principal focus and the optical center, or when the object is at F and O भनेर भन्न सक्नु पर्यो है। त्यो अब यो फिगरहरूलाई एनालाइसिस गर्नु पर्यो कि है। द्याट इज एन्ड वेन द अब्जेक्ट इज एट F and O, and then only you have to draw the रे डायग्राम। इन द सेम वे न दिस रे डायग्राम भने एप्लिकेसन हो, त्यो 6वटा कन्डिसनको त्यो रे डायग्रामको एप्लिकेसन के हो त? फर्स्ट वेन द अब्जेक्ट इज एट इन्फिनिटी थियो अहिलेको है स्लाइड है, द्याट इज वेन द अब्जेक्ट इज एट इन्फिनिटी, त्यसको एप्लिकेसन के हो? द्याट इज युज इन द टेलिस्कोप। इन द सेम वे सेकेन्ड केसमा वेन द अब्जेक्ट इज बियोन्ड 2F, यसको एप्लिकेसन के हो त? द्याट इज इन द क्यामेरा। इन द सेम वे वेन द अब्जेक्ट इज एट 2F, यो एप्लिकेसन के हो त? द्याट इज इन द फोटोकपियर मेसिन। इन द सेम वे वेन द अब्जेक्ट इज इन बिट्विन F एन्ड 2F, यो कहाँ हुन्छ त एप्लिकेसन? यो कम्पाउन्ड माइक्रोस्कोपमा भयो। वेन द अब्जेक्ट इज एट F, यो टेलिस्कोपमा युज भयो। इन द सेम वे वेन द अब्जेक्ट इज इन बिट्विन F एन्ड O, यो कहाँ युज भयो त भन्दाखेरि सिम्पल माइक्रोस्कोपमा हो। त्यस्तै गरी रे डायग्राम बनाउन सोधेर अनि फेरि के पनि सोध्न सके त भन्दाखेरि अल्सो राइट द एप्लिकेसन अफ दिस भनेर पनि फेरि है सोधिदिन सक्छ 1 मार्क्समा। त्यो एप्लिकेसन जस्ट बिफोर आई सेड दिज आर वाट द एप्लिकेसन। सो माई डियर स्टुडेन्ट्स, दिस मच फर टुडे, okay, and remaining just we'll continue in the next class. And still students, that is the this what do we say, COVID-19 one risk has been still not less, okay, it is increasing day by day. So stay at home, okay, if the necessary this unnecessary don't come out of the home, okay. Thank you, stay home, stay safe, keep learning. Thank you so much.
कोरोना भाइरस संक्रमणका लक्षणहरू: रुगाखोकी लाग्नु, 104 डिग्री फरेनहाइट भन्दा बढी ज्वरो आउनु, घाँटी, टाउको तथा जिउ दुख्नु,